First question was basically the first question was this question. So you were supposed to find out which query could be the answer for could be the query corresponding query to this execution plan. Let me open the experiment, or I can. I guess I can open. So this was the execution plan. What happens is you are scanning the index and then you are using hash match, which is basically used for the aggregate, whatever you use the key, you use the title to hash, and wherever the person based on the title coincide with the other groups, then you increase the counter. The hash match is just 5% of the time, and then computing a score. So is that clear for everyone? So this is the only query could be yes, right? So what happens is in order to compute this query, what you are doing is basically you are reading the whole table of person, and you are hashing based on the title. And when you are hashing on the title, if the person is coinciding in one group, then you increase the counter of that group, and this hashing is going forward, and it will be to the end. Then also, what was the next? What was the other question? Okay, this is the other question. So you can see that to extract information about these records, you need business entity ID from employee table. Okay, because the first join is based on the business entity ID from the employee table. In the employee department history, it's a combinational key, combinatory key. You have your key has 3 components: in business entity ID, department ID, and also a start date, right? But if you form a B plus 3, then you can see that business entity ID is forming some prefix for the index. Then this is you can get the benefits of the index, clustered index. For EDH, obviously for employee table, again, as a part of this join, you know that business entity ID is a key in the employee table, then it's clustered index based on business entity ID. This is also useful, this is also useful. And on the department, the key is department. Also, EDH, the department is using also the department key, also cluster key is also used for the departments. So the answer will be what? True. And this is okay, so let's get back out to our. If you get some questions like this, what is the best solution? What is the best solution? Execute it and get the query and see the query and see what is the result. So for example, if I give you another query like this query, which is a little bit bigger, it has nested query inside. You can see that you need to compute this select first, then get business entity IDs where the title is not mentioned, then go for the rest of the table, for the rest of the query. Guessing the execution plan for this table, this kind of query is difficult, but you can use this You can use this icon over here, display estimated execution plan. You can select each part and you can see how that part is executed. For example, if I select this part, if I show it, this will be using a clustered index scan. We are going through the whole table, and basically you check if the title is null or not. Then you create a set. If you want to see the execution plan for the whole query, it will be very big. For example, here you can see that hash match is used twice, and some parts of it using nested loops. And you can also practice with these kinds of pictures and see if you are guessing the right execution plan for different queries. Okay. For the exam, I recommend you to there are some views over here. We talked about views in our lectures. To create a view in SQL, basically what you are doing is you are using create view command, and you are writing the rest as a query, right? So there are a few useful views over here, and for the exam, just go over these views and see what's going on for the execution plan of those views. Check if you consider those views. There are some hints for you, not going through the whole query space, but just checking some of them. I would like to give you a couple of homeworks. The questions are very, very similar to your.
So we have project again.
No, it's good. The homework is first of all, the homework is just multiple choice. And the questions are very similar to what you will have in your exam. Is that okay or not?
Yeah, okay.
Democratically. How many people know? I heard nobody is raising their hand. How many people yes? Many people no idea. Okay, so should I give homework or not?
No. Give homework and cancel phase 3.
Yeah.
That's good
idea.
idea.
Very
We have
It's a
exam
phase
next
3
week,
is
Professor.
very, very, very small. You know what you are supposed to do. You are break one of the tables, rewrite two of the queries. That's it.
Like function, we'll write function.
No, you're not writing. You have to break the. We talked about partitioning of tables, right? What is the horizontal partitioning? You're dividing a table to two tables, okay? And then what kind of benefits you are getting for the partitioning? When is the exam? Next week? The week after next week? And what are the advantages of the partitioning? Horizontal partitioning?
Faster. Performance-wise.
Performance-wise, it's very fast because now you have two indexes. You can search on the indexes parallel. You can do all of the read and write parallel. Okay? What is the difficulty, disadvantage? A little bit more complicated queries. A little bit. It means that you have to just, many of them you have to just use union. That's it. Right? So, don't worry about this. Come on, guys. That's really easy. And I didn't ask any
Phase 2 is very big, right?
What?
So we don't have time.
We
for
choose
the
a choice.
So next week we have full exams.
Because next week many are other subjects are giving final exams, so it will be very difficult to complete phase 2.
Phase 2, what was the phase 2? I forgot.
We have to
User interface or
user interface
Some
or
eight forms we have to create or something like that.
eight forms and
column
Okay,
reports
don't choose user interface, choose the other way.
no, even everything is same process. Like second one is easy, but it takes time. First one is hard, then also it will take time.
What's the first time?
We have to create indexes and like we have to show the execution.
Showing an execution
No, not
plan
that,
is
not
like
execution.
this.
we have to create, you told like we have to create significant amount of data in our database and we have to do.
Okay, you can use, should I,
We cannot use anything, Professor, to
Yeah,
operate the
to
data.
insert data we have to.
We have to write each and every
We can't
query, so we
insert,
have to insert the data. If you have 12
Should I-
tables to insert the
Yeah,
data, it will
like
take a
both are
day.
time taking, I'm not telling you, both are time taking, but.
And we don't have time also.
Yeah, that's what, because it's finals week, we have so much work
Okay,
to do and.
so this is what I'm doing. How many people started phase 2?
nobody's.
Nobody started.
Okay, whoever finishes phase 2 will get 10 points extra. I will increase 15, I will increase first phase and third phase, I will increase the grade of the first phase to 20, right? Okay, and it covers all the 30 points for the project. The project was supposed to have 30 points for you, right?
Okay.
Currently, first phase was 10 points, second phase 10 points, and third phase is 10 points, right? So I make the second phase optional with 10 points extra, and the first phase will be 20 points. Okay? I have to call.
What about third
I don't. If you don't need that 10 points,
What
then
about
I'm
third phase?
okay to just.
What about third?
Third one, do want this partitioning. Really? Yeah. So it's so
So
easy.
20 plus 10, ఇది చేస్తే 10 extra వేస్తాడు.
So even if you want to do partitioning, we should have data reject images.
Puts 3 records on the partition based on 3 records. Partition based on 3 records, 4
రికార్డు
records.
పెట్టి దానిలో 2
Partition.
ఒకటి 1 ఒకటి.
Just partition the table and change your queries, and that's it. And I feel very bad that I cancelled phase 2 of the project.
I know, sir, but these finals will like, we are very near to the end of the semester. We have like other projects from other subjects and we have lots of that's why
We have other subjects in the final exams.
Our final exam starts from 8th of December.
For you 8, it's like for me 7.
Okay, after your final exams, then you will be free until the project presentation will be December 13th, right?
Sir, Professor, you have 4 subjects, Professor. Think in that way also.
we have 4 subjects.
4 subjects actually.
And the same,
It's very high load.
Instead of
during at the
making
same time
optional, you
itself, the
can
final
remove
exams
it
will be there,
altogether.
Professor. Please consider.
I will consider.
నువ్వు కన్సిడర్ అనకరా బాబు. అన్ని కొడతారు. మిగతా వాళ్ళు
Instead
మాట్లాడండి.
of optional, you can remove it,
Yeah,
Professor.
bro.
So why?
Any one page, you do either 2 or 3.
No, some people did it. So if some people brings any result, I'll give them some points out of 10.
So you don't want it to be perfect, is it?
Why? I mean,
Forms.
because I signed the project and some people did this. If I cancel it, the whole thing, then it's not fair to those people who started the project, phase 2.
Okay, then we can cancel
Who
phase
started?
3.
You didn't start? You haven't started? Or
Nobody started.
Monica, you started?
Just like a little bit of database designing ready, that's all. And that's not much.
We are not worried about that.
They are not worrying about that.
If you bring that one also, I'm so generous when I'm giving points. So, if you don't want to bring it, then I can cancel. Yes, no, there is still 10 points optional. You can ignore it. I increase the first place in the point. So,
నాకే ప్రాబ్లం.
if the negotiation on the
నాకు అర్థం అవుతుంది.
in object-oriented databases,
ఒక్క దాంట్లో ఒక మార్క్ ఇదిలో
so the domain of type T is the set of all the objects that can confirm the type, the definition of that type. For example, if you have a type of a student, the first attribute is name is string. The second one is a set of, for example, numbers and his grades. Then if you guys don't want to listen, just if you want to talk, it's okay for me, but keep it low. Other people listen. I'm Mufika. Class is this way. Got that. So, for example, the domain of integer is the set of all of the integers. The domain of a string is all of the strings. And also, if T is the reference, then the domain of the T will be all of the objects that can fit in the extent of that T, right? For example, if T is a reference to an object of a student, then the domain of T could be all of the pointer to reference to all of the objects that are students. That it cannot be pointer to all of the objects like departments. This is like what you have in Java, right? This is exactly what you have in Java. If in Java, if you define a variable as a student, then the pointer to a student or a student, then that variable is referring just to a student. If you use a new operator and constructor of another class like department, then you will get error. Similar to that, this is the same condition it holds here. So the domain of the tuples, for each attribute, A1 to AN, the domain of the tuple is the domain that the set of all of the possible tuples we can create with the domains of T1 to Tn. Okay. So, what is the domain of the sets of T type T? All of the subsets possible to build from to build with values of type T, right? For example, if T is integer, then what will be the size of this domain of T? If T is integer, what is the size of the domain of T? For the last one, I'm talking about the last one. Okay, so if T is integer, then domain of T is what?
All integers, all integer types.
What is the size of this? 2 to the power of all of the number of the integers, right?
Why could you?
Because this is all possible subsets of integers, right? It's very big. Oops. Okay. Okay. Okay, now we start to talk about the schema of the object-oriented databases. How do you define? How can you define a database, object-oriented database? What was the schema of a relational database? The schema of a relational database was the format of tables, the format of the relationships, all of the format of the tuples, possible tuples, plus relationship between those tables, right? For example, a student can have one-to-many relationship with table transcript. This is called the schema of the relational database. So what do we need to have in order to define the schema of an object-oriented database? Whenever you are talking about object-oriented database, because just think about language Java, right? Because you are from these kinds of DBMS, you are expecting the functionality very, very similar to what Java is providing you, for example. However, Java is very, very more flexible and it has a lot of more comments. But
The tuple should represent an object, is that way?
What?
The tuple should represent an object.
The table is
Which
represented
tuple?
as objects, I guess.
No.
This suppose.
In the object-oriented database, like so the
Okay, so in the object-oriented database, if you want to define the schema, you have to define the classes, right? How do you define the schema? How do you design? If you are asked to design an object-oriented database, the first thing you are doing is designing the objects, designing classes, right? How do you design classes? We talked about this last week on Tuesday. You need to define the type of the class and also for each class method signatures. You have to mention that what kind of argument each method of the class is receiving. What else? What did you have in the relational database? You have relationship between tables, right? Here, what is the key relationship between our classes?
Object.
Subtyping, subclassing, right? One class, the class of the student is subtype of a class of person. So defining this subclassing relationship is also part of this schema. Moreover, integrity constraints. What do I mean by integrity constraints?
Primary keys.
Primary key and foreign keys. Okay. For example, if you have a student in table transcript that a student is pointing to another set of objects, the extent of that the student is all of the objects of type students. Okay, right. Also, you can also make sure that you can also put this uniqueness constraint on each other. Like, for example, in the class of students, we can make the attribute of student ID unique. This is key. This key constraints. Okay, so what is the instance of database? The object-oriented database. I mean, you define the schema. So now you are given a set of information. How do you say that? Can you say that this is an instance of an object-oriented database or not? The instance of the object-oriented database is a set of instances of those objects, right? Think about Java.
If
When
every
you're
class is
Java-
instantiated,
What?
if every class is every object is instantiated, then total database is instantiated.
Right. The instance of the whole database is the set of all of the instances of all of the possible objects, right? What is your program in Java? The program in Java is a set of classes, right? Even the main function is a part of a class, main class, right? Here again, this the database instance is a set of extents. Set of extents are the classes. So, and we know that each class, each object in the extent of a class should have the same type of the class, okay? For example, you cannot have an object of transcript in the extent of the students. And moreover, one thing from the last Tuesday, what was the requirement for these classes, for these objects? We talked about this in the last class. We told that when you use new operator in Java, what happens?
New object is
New instance of the
New object is created. We talked about this. When the new object is created, then you are getting back something. What is that something?
reference.
Reference. That reference is called here unique object ID. Again, all of the objects, doesn't matter what kind of objects, all of the objects should have that unique identifier. And also the extent should satisfy all of the constraints that the database schema is enforcing. Okay, so we talked about conceptual data, object data model. We know that how these concepts should be represented in databases. Now, let's talk about two approaches we wanted to talk. The first one is object relational data model. The object relational data model is basically a very simple and straightforward subset of conceptual data model, object data model. Basically, in the object relational data model, the only thing you have is a set of classes, and each class has a set of has a tuple type, and each class means that if it has a tuple type, a set of tuple type, it means that it contains a set of pairs of name and value of the attribute, right? For example, the class of a student contains a set of tuples, right? the tuple type. What is that tuple type? Student ID, string. Student name, string. The student birthday, date. This is the set that we need to have. Okay, so and also what is the form of the tuple? Each tuple is an object of the form object ID tuple double value. What does it mean? The objects are the tuple, right? The class of the students is a tuple of set of values, attributes, right? That value is also as a object ID. So when you are referencing to one tuple, you are just using that object ID. So is that clear? Okay, so in the pure relational data model, what do we have? Same thing. So the object relational data model. So what do we have? What we have here is class is equal to a set of A1, T1 to AN, TN. These A's are name of the attributes. These T's are the type of the attribute, okay? Each class is this form. Okay, here in the object relational data model, what you are doing is you are assigning an OID for each of these. So think about, okay, so suppose that you have this constraint in Java that you cannot have arrays in any classes, okay? And the classes should have only primitive types as attributes. So what happens? So then each class is just a set of attributes of different types, and you can put a name for each of those attributes, right? So here the same thing, you are making it as simple as possible, a set of attributes, but you are assigning an object ID. So that object ID is used as a reference to rows. So here, unlike relational database, in the relational database, how do you recognize rows in the tuples? You are using keys, right? What is used to link between two tables? Keys, right? Foreign keys. The student ID is a key in the student table. There is a student ID in the transcript. Okay, here you may have attributes, but when you want to link between the set of objects, instead of using keys, you have this object ID. Okay, so in Java, what you are doing, you are not using keys. In Java, you have these variables. You put this object ID in the variables, and you are working with that. Here is similar to that. Okay. So, what is the difference between? What is the difference between object relational and pure relational data model? Based on what I defined, what is the difference?
So in relational model we have only primitive types.
Yes.
In object relational model we have any type of the tuples.
Right. Here you can have sets now. Okay. So for example, you can have sets of phone numbers. Okay. Now so you can have sets of. So you can add nested part in the object relational data model. Moreover, here you have this object ID. We don't have any object ID in relational. You have tuples, and that's it. And tuples are primitive types only, but here it can have complex types. Just a review from the last Tuesday. What are the complex types? What are the complex types?
Topology sets.
Sets, tuples, and also reference. Reference was also. What are the primitive types, like integer, string, and so on?
Date.
So you can have complex types in object and relational data model, but the first level is only tuples with object ID, and object IDs are just assigned to tuples. So it means that a set cannot be an object, a single object. Okay? Okay, so now you know that the SQL has been extended to support object orientation. So we are talking about object-oriented SQL. In some of the DBMS systems, you have this option. For example, I guess DB2, IBM DB2 is providing this objects in SQL. In many of the DBMS systems, you don't have this SQL server, object-oriented SQL, or SQL tree. Like for example, SQL Server doesn't have SQL tree, so it doesn't support SQL tree. So object-oriented SQL is an extension of legacy SQL that is supporting objects. Okay, what does it mean? Being as an extension.
It will follow all the concepts of relational database and it will know
Yes.
adding the.
You are adding, and also you are keeping what you had before. So, you still have this concept of relations, okay? So, but you are adding something to the relations. You have this relation concept extended. Now, again, the database is SQL, object-oriented SQL. A database is a set of relations, but now relations can be either pure relations as what we had before, or they can be sets of objects, right? But okay, and also the object is again
A purely tuple or an object ID with the tuple value.
right. Object ID with tuple value. Object ID, like student ID, like ID for the object. We don't see the object ID anymore. We don't see the object ID at all. So at the tuple, name of the student, some string, like well, and this tuple value inside of it itself, it can have other complex types. And also, you can have also multi-set values, as we mentioned. Okay, so similar to what we had before, all the attributes in the tuple value are distinct attributes, and the value of vi for each of these attributes, okay, could be either a primitive type like float, string, or integer. It can also be a reference to another object, okay, or it can also have another type value, tuple value. What does it mean? It means that inside of an attribute you can have another attribute, like another set of attributes, okay? We will see an example later. And also it can be collection sets, right? Okay, so here the relations are, the rows are, the relations in the SQL is similar to what we had before, except we are adding one more type. What kind of type it is? We are adding classes, right? We are adding classes. So we can add rows of
Object.
objects, right? Rows of objects. Okay. Uh,
So previously we used to have address in a separate table, now we are able to have address in a single column.
Here we can have multiple addresses, right? So
Previously we used to partition them, we used to do
Right.
normalization.
you don't need to normalize anymore. So here, so the only constraint you have is that you have to have the tuples at the top level. It means that at the top level you cannot have the set of integers, right? At the top level you cannot have a set of strings. The top level should be tuple. Name of the attribute, value of the attribute. Name of the attribute, value of the attribute. Okay? But this tuple can be nested, can be more complicated. Okay, so we are adding a new type. It's called row types. The row type is enabling you to add tuples as a type of one attribute. Again, we talked about using path of the expressions. Path of the expressions are used to writing queries. Suppose that you have a class of person like this, defined as the name of the person and the address, which is composed of integer, character, and zip. And then, if you are asked to present, if you are asked to show all of the people who are living in the zip 11794, which is the zip code of Stony Brook, then this query will give you the name of the people. How? What is the path? What is the path?
First
What did you do in this select? You were projecting the stuff, right? You were selecting some, you are determining what kind of columns should be selected, right? Here, instead of columns, you are expressing your desire through path. What is the path here? First of all, the where clause. This where clause, similar to what we had before. You're putting a constraint. All of the objects where the address has this zip is selected. So what do you see over here? A person has an address and the address has a zip. It's a path from object person to object address to object zip. Isn't it a path?
Zip will be an attribute, right? It's not an object.
What?
Zip will be an attribute.
So okay, so
Attribute
this
of
is
the
a path,
object.
this is a path through objects. Address is an object, right? And this
P
is a,
and address will be an object. Zip cannot be an object. Zip can be an attribute.
okay, zip is not object, but this is a path. I'm
Yeah,
talking
this is a
about.
path. This is a path.
This is a path from the object P to the zip, the value of zip. So what the only thing you are involved here is the path. You have to be careful about expressing this path correctly. And also here, you also again, you select name of the people. Here, this is also a path from the, you find the object, and from the object you have a path to the name of that person. Okay, so again, for the update operations, similar what we had before. This is a simple query for the update operations. You are adding to the object of person, set of object of person, an object. This is creating an object with these values. John Doe as a name, and the rest will be the address, okay, the type of the address. This object will be created, and then it will be added to the set of what? The set of
Professor,
object
what
of
is that
person.
row means?
Row means the row type. Row means that the type of a set of objects of tuples. Row means that you are nesting a table. Like, you have this person, like row of, like, for example, this is and you can have also, for example, row of, for example, math and B plus. Okay, so you can add rows like this. Row is a subset, a tuple. This is a tuple, right? This is a tuple. It has also its own values. Like the first one is, for example, course name. This is a type of grade. So this is the shape of nesting, right?
So if you want to create such a kind of table, so what will be the query? Table. If you want to have a table with a name and some address or like.
Create table, right? Okay, so we'll have create table. Right? So these are, before getting to the creating table, this is, for example, updating a person, like, for example, similar to previous type, you're changing the zip of the address to 666 if the address is is 555, okay? So there is a set of person, there is a set of objects of person. In that object, you know that there are a set of addresses. In that addresses, you are checking. So what is the difference from this way on relational, pure relational? Forget about a set of rows. Just suppose that you have one set of rows, one row. Suppose that each person can have only one address.
In pure relational, if you give person, then directly it will be like zip or.
Yes, exactly. In pure relational, you're directly accessing zip, and zip is identified by the person. But here, zip is a part of address. So this is, you have this hierarchy. You have this hierarchy and abstractions. Also here, for example, each row of this format will be changed to this row. You know, like. So, in addition to row types, you can have now user-defined types. What are the user-defined types? Classes. Exactly like classes. User-defined types means that user can define it. Okay, but it is a type of complex objects. Complex objects and types. Like, for example, you can have a type of a student, right? That type of a student is a new type that you are adding to the table. In the relational database, you didn't have it, right? You didn't have any, you cannot have define a type of multiple attributes and then use it. But here you can. Okay, so user-defined types can have components of non-primary data type. Okay, so here, finally, this is how you define types or classes. Create type, person type as.
This is type as a table, you're saying?
This is a defining a class of person type. Okay, think about type as a class, right?
Type as a class. So,
Yeah.
I mean, in the data table perspective, it is like a table, you're saying?
In a database perspective, here in this database perspective, internal it keeps it as a table, but now you need to just think it as an object, complete object. When you define this type, person type, when you instantiate some instances of it, then those instances will get this unique ID, object ID. They will be stored and managed in a different way. So here, person type is defined as a name, and this a row type, right? Okay. There is one more relationship between classes. What is relationship? Is a relationship, right? By inheritance. How do you define inheritance?
Extends Java.
Here, in Java extends here under. Create type students under person type. It means that the student is inheriting all whatever person had plus something more, like integer as an ID or status as a character. You have one more thing to be added. What is that for classes? Functions, right? Methods. You remember the function we had for the movie frame range, the previous class? So that frame range should be defined somewhere. So how do you define it here? You have this expression method, the name of the function, the name of the method, return type.
So only one function for one class?
No, we can have several functions. So,
But you are not declaring it inside the class.
again, I can put it over here.
Okay.
This is the definition of methods, right? This is a method defined and a word. We add it over here.
What is
Oh,
language
sorry.
selection framework?
You are not adding it over there. You are using it here. Create method award for student type. So you can have several methods, right?
We are creating a method here and we are using the method over there. Is that?
What? No, we are not using it now. We are just defining it. Create method. This is the name of the method for which type? Student type.
Then what is language CNXT?
Return
Okay.
language.
What is this? This is the address for the binary code of this method. Where is the binary code? This is in this file. What is the language of the binary code? C. It's object-oriented SQL can parse and generate some of the
How is this different from a user-defined function?
user-defined function.
Yes, functions are.
In user-defined functions, the only thing you can, the language you have is just SQL, right? Here we have C language. This is compiled. This is a compiled program. Okay, this compiled program can, for example, select a range of or change the color of the image, right?
So we also can take input for our degree. We can pass any input.
You can have pass any input. You can pass. One more example. Okay, suppose that you have an object of image. Okay, here in this function, you can define a Boolean function that is going and reading the image and recognizing that if the image has a shape of a face of a person. That's an example of this. Oh. What is going on? Okay, I ran out of the space on my computer. Unfortunately, I cannot record anymore for the students. Okay, so they can follow the rest of it from Bennett's videos. Okay, now you can use user-defined types in the tables, right? So for example, here you have a table transcript. In the table transcript, you have a student type. In the student type, you can put students. Or you can create a table of a specific user-defined type, like create a table of a student from all of the classes you define for the student type. This is called type table. Okay.
Question.
Yeah.
So, object-oriented databases were using classes instead of relations. And so a table is like a class. But we also have user-defined types, which are also like classes. So a table can have a user-defined type, but can a table have a reference to another table?
A table, the whole table, you mean the whole table, the set of whole tables?
I mean, like, you know, in Java we have a class as a member of the class, we have a reference to another class, to another object.
No, definitely in the, here, for example, suppose that this is a, suppose that you are defining here in the person type, you can, if you define a type of course, for example, or the type of major, which is defining the major and all the syllabuses, okay, then you can add that type to the this type, right, as a one attribute. So this is like one type is referring to another type. And for example, when you are enrolling to, for example, computer science, then the reference for the computer science major will be added to your object, to your field.
But, so a table can have a reference to a type, or can use types, but tables can't use other tables.
Tables, when you're talking about table, if you consider a table as a top level of a table of types, like all of the objects, all of the materials in it as a type, you can, okay? But yes, you can.
Okay.
You can use it as a set of tables. Yes, you can point a tuple to a set, right? You cannot. Okay, so only here, where are the objects are stored? Where are the objects are stored? Where do you store objects? We created a type. We had this type of tables called type table, right? Create table, student or student type. Okay.
Obviously, in the student table only.
Right. Peter, you are pointing to the whole table from a table. You mean pointing it to, you know, like for example, you mentioned that in this case. Let me get back to your question. Probably I didn't get it, or I gave the wrong answer to your question. You mean that you have this table, okay? This attribute in the table is pointing to another table, to a table, and the table should be a type of, like this table. This is different from the other one.
Yes.
The whole table, like this is a student table of the students. This is a table of, for example, transcript.
No, that wasn't exactly my question.
So
my question is like, I'm trying to translate to like see how similar object-oriented databases to normal object-oriented programming languages, right? And so it's weird because you have tables that are like classes and types which are like classes.
right.
Right, and so I was wondering if, just like in Java, we can have we can have a class which can have objects. Can a table have other tables as part of it? Just like how an attribute in a table can be a type, which is like a class.
Right. So here the one answer is row types. Okay. This row type is a table, right? This row type is a table. Some sort of one table is if you have a table of person, that one table you have a table in it. This is what you are looking for, right? So this is some sort of nesting, but similar to what you have in object-oriented languages. But if you want to just point it to another table, just to some rows in another table, this should be a reference, okay? Then this cannot be a table directly, it should be a type table. In the types, you can reference to another objects, right? For example, in type of student, you can have a type You can have an attribute of type, for example, desired food, which is pointing to the foods, right? So in that case, if you create a table, type table for that students, then it's referring to another table which is containing all of the objects of foods, like sushi, pasta, and so on, right? So this is also referencing to that. Okay, we will continue on Tuesday. You just remember that Tuesday, 13th of December is the day that you will bring your projects and you will present your projects in a few minutes. You have just 2 or 3 minutes. I will ask questions from everyone in the group, and if I realize that someone does not have any contribution to the project, then the grades for the project will not be equal, right? So is it fair? Because I am expecting all of you to contribute to the project at least.